All right, so here we're going to go over chapter 8, which we're going to start out with sampling distributions, and which is similar to normal distributions. The big difference here, and again, I could go through all this, but let me charge my writing tab. Plug that. So I'm going to skip through all of this because this is just a giant waste of time to go through. Okay, huge waste of time. I'm going to skip all of it. Okay, we're going to go right down to here, central limit theorem. Okay, and this is what we're going to write. Normal distribution, basically in chapter 7, your z-score found using this formula, and not what I want. Your z-score is found using this formula. Z is equal to x minus mu over sigma. That's all we needed. Okay, this is for normal distribution. Normal distribution. Okay, now we're doing sampling distribution. Now here's the difference, and here's the only difference. Normal distribution, your sample size, your n, is 1. Okay, with sampling distributions, you have an n that is greater than 1. It can't equal 1. It has to be at least greater than 1. Okay, so, and usually like 5 is the limit. Okay, usually you have to have at least 5 because honestly it's just a waste of time otherwise. So even then that's really tiny. Now here's the difference with z. All right, because you have a sample size, you're not going to have a random value. You're going to have a sample mean. So x becomes x bar. If you remember, x bar is the sample mean. All right, that's the mean of your sample. Mu is your population mean still. Okay, over this right here, which is this part right here. And again, I would circle that, but it's in white right now. So sigma divided by the square root of n. And that's your formula. That's the only change from chapter 7 to chapter 8.1. Okay, now here's the really fun thing. This is all you're going to change in R. Let me go to R, scroll up here because here's our formula. That right there. That's the only change. Everything else is the same. You still round, p-norm. This question, I think this was on page. I used a question from the book. So if you want to find this question, it is. Where go? Okay, this is on page 425. I'll put this in the notes. Page 425. Okay, and this is example 4. Now, again, there always is a bit of difference. They got 0.1003, and that's because, again, there's no rounding until we're done here, where you're going to see that they're going to round the denominator when they plug in and when they find z. And they're going to round z to 2 decimal places, and then they're going to look it up in the chart. We're not going to do that. We're going to be more accurate. Okay, so I'm going to go with a more accurate answer here. And again, we're off by 5/10,000ths of a decimal point. They got 1.003. We're close enough. Okay, so that right there is the only change. You have to include your standard deviation to be divided by the square root of the sample size. All right, so that's 8.1. Right, I'll put some homework questions up for 8.1 in a bit. Let's talk about 8.2. That's the one I really wanted to go through. Okay, so let me click this. About that. So distribution of the sample proportion. So this is different. Okay, this is sample proportion. It's different than sample mean. It's a proportion. Okay, so instead of looking for mean, we are given a proportion. Like, for example, let's say that there's a certain percentage of people who are expected every year to be diagnosed with a certain type of cancer. Okay, now we could ask, what's the probability that it's higher than that, or what's the probability that's lower than that? Okay, or higher than a certain percent, or lower than a certain percent. Okay, so we're, in this case, we're not given a mean, we're given a percent or proportion. So we want to find a way to do probability distribution with a proportion. All right, so here's the thing. P hat is our sample proportion. It's found by taking x over n, so you're going to want to write that down, how to find p hat. It's how many meet the criteria. So example would be in Winnipeg, whatever, 1,745 registered voters nationwide were asked whether they approved the way George W. Bush is handling the economy. 349 responded yes. Obtain the point estimate for the proportion of registered voters who approved the way. Again, point estimate will be 349 over 1745. As a decimal, 0.2. Okay, that's how you find p hat. Now, according to the time poll conducted, 42% registered believe that gay and lesbian couples should be allowed to marry. Describe the sampling distribution of the sample proportion for sample size n, 50, and 100. Basically, you just multiply it by the percent. Okay, so yeah, I'm not going to have you do this part, so I'm going to skip quite a bit of this. I'm not going to have you do the sampling distribution really at all. What I want you guys to be able to do is to, one, find p hat. Okay, so find p hat, which is x over n. So again, let me write down the formulas you need to know. So over here, so p hat is x over n. Right? Here, this must be true. In order for your distribution, and you might be asked to determine whether you have an adequate information for a sampling distribution. This must be true. Okay, so basically you have to be able to prove this is true, which is your sample size times the proportion times 1 minus the proportion. That has to be greater than or equal to 10 for it to be an adequate sampling distribution. Okay. Your mu value, remember finding z? Okay, so again, z is equal to, before we just did this, z is equal to x bar minus mu over sigma divided by the square root of n. Well, instead of doing that, we're going to have this formula. Erase that. Don't need it right now. We're going to have z, and z is equal to p hat minus mu of p. By the way, mu of p hat is the expected value, the expected percent. So you'll see what I mean, what that is in a second. So we're going to say just p. All right, over sigma, okay, which is going to be this fun thing, square root of p times 1 minus p all over n. And that is how you find z. So if you're asked to find z, you just plug this in a calculator, okay? You have a calculator somewhere, download one, easy enough to find a calculator, all right? So that's how you're going to find z. So mu p hat is equal to p, sigma p hat, so sigma for your proportion distribution is this one thing, the square root of p times 1 minus over n. So if you're asked to find either one of those, so I'll leave those up there so we can see. All right, so here the model from the previous slide requires that the sample values are independent. When sampling from finite populations, the assumption is verified by checking the sample size is no more than 5% of the population. Okay, regardless whether this is true or not, the mean of the sampling is blah blah blah. Okay. So describe the sampling distribution from the sample population, given that we sampled 50 voters, so we have n is important information over here. So we have, this is my 42% of the registered voters believe that gay and lesbian should be allowed to marry. So P is equal to 42%. Okay, N is equal to 50. All right, describe the sampling distribution. On here, again, P is 42, N is 50. We're greater than 10, so we're good. All right, sampling distribution. Sampling distribution of the sample portion, therefore, is approximately normal with a mean of 0.2. So plug in, there's your sigma value. Okay. Compute the probabilities. Now, this is where I'm going to have you do most of the work, okay? Because R does it for us. I found a nice little program that works on R, really easy. So I'm going to give you the R formula in just a second. But we're going to look at this question. Okay, so according to Center for Disease Control and Prevention, 18.8% of school-aged children aged 6 to 11 were overweight. And a random sample of 90 school children age, what's it probably at least? So that means greater than 19%. Okay. So let's write the important information. Hopefully you have this down. Important information is that what was it? P-value is 18.8%. My p-hat is 19%. And N is 90. That's the only things you need. And we're doing at least, which means greater. Okay. So here we're going to go to R. We're going to use formula. Okay. We're going to use this formula. I know we can't see that, so I wrote that a different color. So you can kind of see it. Right? Now, X is not the same thing. So let's do this in a different, let's say, whatever that color is. So X, we're going to have to say X is the actual number. It's not a proportion. It can't be a percent. So X is found by taking p-hat times N. And that's all I'm going to put. I don't have to change anything. I don't have to actually find X. I can just do p-hat times N. In this case, it's going to be 19% or 0.19 times 90. I just leave it like that. N is 90. So N we know to be 90. P is P. That's the proportion we're given with the beginning. So P is 0.188. Again, I think you can type in the percents, but I'd rather just type in the decimals here. And then this is the pink thing. Now, I'm actually going to leave all this on there. I'm going to post this. This right here can be one of two things, okay? Either it's, or one of three things. Either it's two-sided, which by the way is default. If you actually don't put this in there, it's going to be two-sided, which means between, and you don't want that. So it's going to be less than or greater than. For the most part, it's going to be less than or greater than, okay? We're not going to do two-sided for any of this. Two-sided is if we're doing confidence intervals, which we haven't talked about yet. So that is chapter, don't remember. So, yeah, we're either going to do greater than or less than, okay? Now, you can specify, again, we don't really care, just type in less than or greater than. Less or greater, that's right here. Less or greater, okay? And then correct. This has to be written here because if it's left blank, it's going to be assumed to be true. We want to say a logical indication whether Yates continuity correction should be applied. We don't want to do that. Okay, we just don't. None of the questions want us to do that. And it took me a bit of trial and error to figure that one out. But hey, I did it for you, so there you go. This is all we have to put in. So we're going to put this in. All right, we'll put this in. Now again, like I said, I don't have to type in, I don't have to find that value. So I'm going to do 19 times 90. And then a 90. And then this was 0.188. Now you're going, and we want less than this. Now we want a greater than. We want a greater than, so it's greater. I'm good. Now you're going to get all this information. So let's see what we're going to get here. Figure this now. All right. So this was the data. All right, 19 out of 90, no probability of that right there. This is what we're looking for. Right? That's what we're looking for. Right? Let's see how we did. 19. Wait. Second. That's greater than, right? Oh, that's 190. Okay. Yeah, make sure you're correct here. All right. So there's the p-value. I think we're correct here. Nope, something else wrong. Yep, just like normal class. I gotta figure out what's going on with R. Okay. That. Not by that much. Okay. Nope. All right. Oh no, we're right. Okay, sorry. I looked at part B. Yeah, 0.4801. Yeah, I'm good. Now again, we're off by again 5/10,000ths of a decimal place. So that p-value is poor. I was right. I was looking at the wrong answer. That's what the problem was. I bet you guys are going, that's part B, not part A. Okay. So, all right. So we're looking for the p-value, which is 0.4801. So yeah, there we go. And again, I did another one just to see what's going to make sure it worked both true or false, less than and greater than. This was on page, what is this? Page 439 in your book. Yeah, page 439. This is part B of example 4 on page 439. This was part A. I just deleted it for the practice problem that was on the PowerPoint. Okay. So, suppose a range sample 90. What might we conclude? What we expect? Results in 24 overweight children. All right, let's put in 24 instead of what happens. So we're gonna put in, instead of 19, we're gonna put in 24, and we're gonna just do less than. Or we can keep it as greater. Okay. Oh, it's 24, which is greater. Okay, I'm gonna say greater because that is greater than 18% of that value. All right, so 24 is greater than 18. That's why I'm gonna go with greater than. So suppose the sample is 0.6, which is greater than 18%. Yeah, we expect to see about 3 samples in 100, resulting sample of point or more. This unusual sample, again, that's fairly unusual. And I don't even need to even answer all that, because here we got a p-value of 0.0281 if you round. Okay. So yeah, that's less than around 3%. So that's unusual to occur. Have 24 overweight children out of 90. So that's how we're going to do this. That's how we're going to do finding probability of proportions. Okay, now if they give us x, we can just type it in. If they give us a percent, we just multiply it by n. Right? And again, we're looking for p-value. My answer is p-value. We haven't done confidence intervals. We're not going to worry about confidence intervals right now. That's something else. I got rid of the confidence interval part because we're not worrying about confidence intervals. It's just going to spit out an answer for it anyway that's actually nothing to do with anything. That's all we're looking for right here. Confidence interval. Or sorry, p-value. We're not looking for confidence interval. P-value. That's what we're looking for. So we're back to that question. Okay. And that's the end of that PowerPoint, and that's really the end of chapter 8. So I'm going to post some homework to do. It's going to be basically the only thing you're going to need are the simple formulas you can either run on a calculator, or it's going to be these two formulas for running on R. Okay, you're not going to need anything else, I promise, and nothing else. Either it's something you can do on a calculator, all right, which means finding your new standard deviation using that formula. Either going to be the formulas that I wrote down for that second part, or sigma x bar is equal to sigma divided by the square root of n. Either that, okay, from this is 8.1. That's probably the only thing that you need a calculator for, maybe to find z, okay, where z is equal to x bar minus over sigma n. You might have to do that, but again, you can do that on R as well if you want. Just make sure if you do it on R, it's going to be x bar minus parentheses sigma parentheses. That's where that SQRT comes from. It means square root. All right. So that's about it for the formulas for 8.1, and I think I already went over all the formulas for 8.2 that you might go back to it. There we are. 8.2. Okay. Finding p hat. You may just be asked to find p hat. All right. Or you might be asked to there it is. Determine if you have normal distribution. This is basically, as long as this is true, you have normal distribution. Okay, so if it asked, do we have enough information for normal distribution? Is my sample size big enough for normal distribution? That's what you're going to do. If it's greater than 10, you're good. Okay. You might be asked to find z. Again, we wrote down the formula for z, which is down just a reminder. Formula for z. Z is equal to p hat minus e over giant square root 1 minus over n. Okay. I wouldn't put this on R. I mean, you could, and if you really wanted to, it would be parentheses p hat minus close parentheses divided by SQRT 2 parentheses b times b close parentheses n close another. So there's a lot of open and closing parentheses there. Okay. So if you want to put an R, that's what you would do. Have fun with it, okay? Other than that, you're just going to need your probability formula, which are. That's everything. That is chapter 8. I'll give you guys about, again, like a couple days to get this done. We have quite a bit to cover, so we're going to cover chapter 9. I'll probably post that either on Thursday or on Friday for you guys to do work over the weekend. Because again, what else are you doing? You're stuck at home. Again, I would say you have other people's work to do, but SLU is requiring me because it's an 1818 course, and if you signed up for the 1818 course and you're going to pay for it, they're requiring me to still make sure you do work and test and have grades, because yeah. So yeah, please make sure anything that's SLU, make sure you get that done at least, okay?